In an industry that builds nations, information is power. Insight is strategy. The steel and mining industry drives the backbone of modern infrastructure. But in a rapidly changing market, every decision needs reliable intelligence. It began with a simple idea: a morning WhatsApp news update for the steel and mining industry. The updates quickly gained industry participation and credibility across the sector. This growing community led to the formation of Metalogic Research and Advisory. During the global disruption of COVID, we launched our digital intelligence platform, mymetalogic.com. A central hub delivering market intelligence, industry analysis, and strategic insights. From daily market movements to weekly strategic analysis, our reports keep the industry informed. Our consultancy services support businesses with market research, commodity pricing, and industry analysis. Through MyMetalogic memberships, industry professionals gain exclusive access to market intelligence and premium reports. MyMetalogic, intelligence powering the future of the steel and mining industry. India's steel and mining industry is evolving faster than ever. But real progress happens when ideas, technology, and leadership come together. With 10+ years of experience, Metalogic has been connecting the steel ecosystem through impactful industry platforms across Pan-India. We bring together CXOs, plant heads, innovators, and decision-makers shaping the future of steel and mining. Focused events for the steel and mining sector. Tailored, customized events designed for your business goals. Research-driven forums delivering real industry insights. Powerful product and company launches that capture attention. Because we don't just host events, we create industry brands. From brainstorming sessions to live demonstrations, we create spaces where innovation comes alive, and exhibitions that showcase the technologies shaping tomorrow. Metalogic events, connecting ideas, industry, and innovation. Join us to shape the future of steel and mining.
So, good afternoon, everyone. A very warm welcome to all our distinguished speakers, industry experts, and participants joining us from across India and around the world. I am Monica Bachchan, Duvuri, founder and CEO of Metalogic Projects Management Services, and it is my pleasure to welcome you to Metallogic's 66th webinar on high performance coating for pipes, tubes in water, oil, and gas applications. Thank you for all taking the time to join us today. Before we begin, let me quickly share a little housekeeping announcements. This webinar is being streamed live on our YouTube channel. So just in case if you're feeling any difficulty on joining on Zoom, you can go to Metalogic PMS. Industry friends who would benefit from today's discussion, please do invite them to join us. We encourage everyone to actively participate throughout the session. Please feel free to post your questions in the chat box and we will take up as many as possible during Q&A session. And here's something exciting. We have a live quiz at the end of the today's webinar. So stay attentive, take notes and listen carefully to our expert speakers. It's a great opportunity to test your knowledge and make today's session even more interactive. I'm delighted to have a co-moderator with me today, Mr. Rakesh Thakur, founder of Pipeline Solution Services from Dubai. With his extensive international experience in pipeline engineering and global projects, I'm sure his perspective and questions will add great value to today's discussion. I'd like to make an announcement that we are also doing a physical conference, Metalogic 9th Annual Conference on Make in Steel, Make in Bharat on 13th of August at Lee Meridian in Delhi. So do join us at the conference as well. Now coming to today's topic, pipeline form the backbone of critical infrastructure, whether transportation, drinking water, oil, natural gas, or industrial fluids. Their reliability depends not only on the quality of the steel, but also on the effectiveness of the protecting coating. High performance coating are much more than just a prospective layer. They are essential for preventing corrosion, extending service life, reducing maintenance cost, improving operational efficiency, and ensuring the safety and sustainability of pipeline network. As government and industry continue to invest in infrastructure and energy security, selecting the right coating technology has become a strategic decision rather than just a technical requirement. Today's webinar will explore the latest coating technologies, international best practices, evolving standards, regulatory developments, and the future of corrosion protection for the pipeline and tubes industry. We are privileged to have an outstanding panel of experts with us today, representing manufacturing, research standards, and international project execution. Allow me to introduce our esteemed panelists. We have Mr. Shomendra, founder and director of Amchem Products India, and a recognized expert in protective coatings, actively contributing to BIS and AWA standards for water pipeline coating systems. We have Mr. David Peck, operations and project manager at Tabteen and Corrosion Prevention Technology Company, joining us from Kingdom of Saudi Arabia with extensive international experience in pipeline corrosion prevention and advanced coating solutions. We have Mr. Maheshkumar Aradhye, PCS, Senior Director R&D, Protective Coating and General Industrial Use at Nippon Paint India, and an AMPP International Certified Protective Coating Specialist and an inspector with deep expertise in coating technologies, corrosion protections, and industry training. We have got Mr. Arun Kumar Gupta, Associate VP, Operation at Jindal SAW Limited, bringing decades of expertise in the manufacturing and operational excellence of steel and pipe for critical in infrastructure projects. Ladies and gentlemen, please join me in extending a warm welcome to all our esteemed speakers. We sincerely appreciate you taking the time to share your knowledge and experience with us today. So without any further delay, let's begin our discussion. Starting from Mr. Mann. Mr. Mann, it's a pleasure to have you with us. I request you to please unmute your mic. My first question to you is, you have been actively involved with BIS and AWA Standardization Committee for polyurethane, external coating and internal lining. Based on that experience, where do you see the biggest gaps in the current standards and what improvements are most urgently required? Over to you, Mr. Mann.
In my view, we have some major issues in the current standards. Now, when we talk about, say, a standard, our C222 for polyurethanes or our C210 for epoxies, the gap is that we have the same performance requirements for both the internal lining as well as the external coating. Whereas the environment in which they operate are completely different. The internal lining is fully submerged in water. The corrosion and the coating failure mechanism is different. The external side is buried in soil. We have exposure to salts, oxygen, water vapor, and also, more importantly, the cathodic protection current. So the environments are very different, yet we have the same performance requirements for both internal and external. So what I would like to see going forward is to bifurcate the requirements for both these sides. That's one. And in fact, I have recently raised this issue in the our C222 committee. I am in the SWAMTech and the C222. So it has been recognized, and going forward, we will take a lead in making amendments in the standards. One another issue which I see is that the standards do not address the lifespan or anticipated life of any system. So if, just for example, if we take, say, our C210, internal is 400 microns, nowhere does it say what is the expected life in a normal environment. The only way we can get a correlation is from a standard like ISO 12944, which says that, okay, if you are going for a 400 micron lining, you can expect a 15 plus year life. But a 15 plus year life is very insufficient for a pipeline, because the pipe is not going to be planned for 15 years. It's going to be planned for 30 years, 40 years. So the coating thicknesses and the expected life, this is some area where we need to work on in the standards.
Right. Thank you, Mr. Mann. Going forward to Mr. David. David, Rakesh from our team would like to take a question from you. Rakesh, over to you.
Hello, David. How are you?
I'm good, thanks. Rakesh?
Yeah. Yeah, I would like to ask you, you are coming and representing CPT based out of Saudi Arabia. We have noticed the many GCC countries, including Kingdom of Saudi Arabia, have successfully used the cement mortar linings for internal linings for potable water for the last decades, few decades. So what are the biggest advantages they have considered while specifying this product? And what's the service lifetime, which we were discussing just now, does CML provide?
Yeah, Rakesh. I've been in the Middle East 16 years now on various projects. Cement lining is predominantly one of my specialities. I was project manager on the Fujairah Phase 2, on the Fujairah Phase 2 project from Al Ain in the UAE up to Fujairah. I'm currently projects managing several large bore desalination pipelines, water pipelines. The biggest one being a 600 kilometre, 100-inch pipeline from Jubail desalination plant over to Fujairah. Cement lining is proven, tested, and it's probably the least costliest of the internal linings for water. So that is its benefits. It will reach the lifespan the designers want if the pipe is laid correctly, if all test plans and quality plans are basically observed, and that's where you will get the quality for it. Hence, the program we've got in Saudi Arabia on some of them is where you get a specific pipeline project. We will take the mobile batch plants which are computerized to adjacent to the construction site where the pipelines. Hence, even saving more money. Our mixed design is tried and tested. It's changed a lot from the very old days when I was back in the UK lining cast iron pipes. It was just Portland cement and sand. Now our mixed design is a lot more kind of technical, added microsilicas and so on and so on. Every project we go to, we have a lab on there. Everything's tested, permeabilities from chlorine and water permeabilities. So it becomes a science as such, and if the quality is followed, there's nothing what beats kind of cement lining, if you ask me. Don't get me wrong, I've lined on rehabilitation with epoxies and all that, and I'll swear by it on the small bore rehabilitation jobs and so on and so on. But on big bore, long distance, the cement lining is durable. Anything else?
Yeah, so thank you, David. I'll come back to you on the next question. Coming to you, Maheshi, despite advancements in coating technologies, corrosion specifically, in oil and gas remains one of the biggest challenge in pipeline infrastructure. In your opinion, what are the most common causes of coating failure? If I ask
Thank you so much, Monica ji. And you have asked a perfect question. You have asked the pipeline infrastructure. Now, when we say a pipeline infrastructure, it doesn't mean only the pipe. It's the whole infrastructure created with pipe. Now, if you visit to any of the pipe industry, you will find that people are working meticulously to give the best of the best quality. The coatings which are provided to pipeline industry are again meant to perform. Okay, but when it comes to infrastructure, when the pipe is dispatched from the pipe mill and when it reaches to the site, there are certain issues because of the pipe's heaviness. Okay, the coating somewhere it may get erupted. Okay, that is one thing during the transportation. Second thing, when it comes to the pipeline laying, the care has to be taken. Most of the time that care is taken, but during that time also there is a possibility that the coating may get erupted. The third thing is when you join the two pipes, pipelines are normally 10 meters to 12 meters. Okay, you find linings, you find pipelines for kilometers across. Okay, when you join it, the proper treatment has to be given onto the weld joints. The weld joint is one of the weakest link as far as the pipeline infrastructure is concerned. And unfortunately, maximum problems of corrosion are arising or to the weld joints. Okay, now the pipelines are protected two ways. First, with the coatings. Second, with the cathodic protection. Whenever the cathodic protection is present, the ultimate aim of any pipeline coater or pipeline manufacturer is that to choose a coating which has got a highest dielectric strength, to choose a product which has got best cathodic disbondment resistance. Okay, and most importantly, the adhesion. Unfortunately, I would say this unfortunately, the specifications which pipeline coaters do get are, I see, it seems that these are cut, copy, paste kind of a specification. These are cut, copy, paste kind of a specification without considering the actual final uses of it. Now, the performance coating selection is totally dependent upon the atmospheric condition in which that particular pipeline is going. Okay. That particular study is not carried out. And as I told you earlier, the weakest link is the weld joint. Weld joint internal, weld joint external. Now that particular area where the coating is left out has to be repainted again, reblasted again, and repainted to the original of it. Now there are a lot of field joint coatings which are available, and wherever the field joint coating are applied, the rate of failure is always less. But wherever the field joint coatings are compromised or applied in a compromised kind of an environment, then the possibility of failure increases dramatically. So what we can do in this particular thing, the first important thing is understand where the pipeline is going to be. Try to get the answers for the questions that why you want this particular coating, what are you are expecting from the coating, what should actually achieve from the coating, and what you should be doing to achieve that particular performance of the coating. Not that the specification is saying this and I'm achieving this and I'm done for this. Means I may be wrong in one particular say that the specification is saying this and I'm doing this. No, I don't want to say that. The specification writer should take in consideration that this particular pipeline is moving through this particular infrastructure. The atmospheric conditions will be this. It will be facing such type of a cargo, and then only he should suggest that you should go for this kind of a coating onto the pipeline infrastructure. Or and otherwise, the failures are 100%.
Right, sir. Thank you, Mr. Mahesh. Coming to you, Arun Kumar, sir. As one of the India's leading pipe manufacturer, how has coating technology evolved over the last decade, if I ask you, and what quality control measures are most critical to ensuring long-term pipeline performance? Over to you.
Thank
Arun,
you,
sir.
ma'am. If you think there was a company, PSL, who introduced the coating in India in 1984. Then in 1995, Jindal started this coating plant, and fortunately, I was the part of that plant. That time, there was not much awareness about pipe coating among the people or among the clients. There was only one client in gas pipeline, GAIL, who was asking for only external coating, 3LP coating. Then IOCL, they were asking about coal tar enamel coating, which is now not there because of environmental issues. And then if you will talk about water segment, there was only inside cement mortar lining and outside goniting. Then in 2012, especially in Gujarat government, we introduced some presentation on the advantages of 3LP coating and internal liquid epoxy coating over CL. And after our efforts, they changed the entire specifications. So what I have seen in industries and among clients, that Now they realize the importance of coating. Earlier they were thinking only about pipeline, but now they realize. So now gas companies, they started internal coating like flow coating with 60 to 80 micron. Then water pipeline, they started food grade epoxy. And now the new concept is coming. Most of the people is having not much awareness about that. The Jindals have first introduced that, the internal fusion bonded epoxy powder coating, which is having much more better performance and much more lifespan in the coating. But the bigger challenge is the cost. When we are talking about water pipelines in India, people are first talking about the cost. That's the biggest challenge. But the good thing is now people are thinking on that, how we can start the good things. If you will see this FB coating, the biggest challenge is cost and then biggest challenge is size. If you will see the water pipeline, that is all above 80 inch. That is very difficult. But if it is up to 56 or 64 inch, I can say the IFB coating is the best coating for inside coating.
Okay. Thank you so much, Arun sir. So audience, I'm raising a poll question on your screen. It's time for vote. So you have 5 questions in front of you. So the audience is able to see the questions. Your question number 1 is, which sector do you represent? The options are water, oil and gas, steel producer, coating, EPC consultant. Please vote on that. And the second question in front of you is, what is the biggest challenge in ensuring long-term pipeline performance? Your options are corrosion, poor coating quality, improper installation or handling, or lack of inspection and maintenance. Question number 3 in front of you is, what is the most important factor when selecting a coating system? Your options are 3-LPE or fusion bounded epoxy, polyurethane, or throughout the project life cycle. Question number 4 in front of you is, how familiar are you with BIS, AWA, ISO coating standards? Your options are very familiar, somewhat familiar, basic knowledge, or not familiar at all. And the last question in front of you is, in your opinion, what contributes the most to extending a pipeline's service life? The options are quality of steel or high performance coating, proper installation, or regular inspection and maintenance. Now, since the audience is busy in voting, I request Rakesh to take up the next question from Mr. Mann.
Yeah, Mr. Mann, if you can unmute yourself, I would like to ask you a question on this internal lining.
Okay.
The safety of drinking water pipeline lining is closely or directly linked to the public health. So based on your experience from India and international markets, I understand you are as well working in Southeast Asia, Europe. Right. So do you think current standards are adequate, or what are the key regulatory change or stricter requirements are maybe you foresee for potable water contact materials as we go forward?
Right. That's a very important question, and I'd like to bifurcate into 2 separate. One is for the Indian market, and one is for the international markets. In the Indian markets, because we did not have a domestic standard, which was specifically addressing the extraction of harmful substances from coatings and linings into the water, we, or rather the users like the PhDs, are all currently following WRAS or NSF 61. So the coating or the internal lining has to meet either WRS or NSF 61, because the IS standard IS 10500 largely addresses only the quality of water, but not the extraction of harmful substances from the lining to the water. Fortunately, there has been a change in this. The BIS has constituted a working group under CSD 20, in which I'm also one of the lead members. And we are now coming out with a standard for detection of harmful substances from epoxy and polyurethane linings into drinking water. The draft standard is, I think, about 95% ready. We are running some tests for the initial washing period, and then it is my hope that by the end of the year, it will be ready for publication and rather public comment. So that's as far as the Indian context is there. Coming to the international context, in terms of existing standards like NSF 61 or WRS, what we see is there is an increasing look at forever chemicals, which are the PFAS, which will be put under more scrutiny. Microplastics will be put under more scrutiny. So that's as far as the NSF is concerned. But the biggest change going forward, and it's very imminent, is what is happening in the European markets. The Euro 27 standards are being implemented from the 1st of January 2027. And this is a unified standard for all the European Union countries. So in one sense, it's very convenient for the vendors to get your product approved. You don't have to get individual registrations done, say for every country, France, Germany, Switzerland. You can get an approval unified way. But the challenge is that the European 2027 standard has a different approach from NSF. So NSF really doesn't concern as to what you are starting with. So you could use practically any ingredient, and the NSF is an extraction standard. So they will test what is extracting out at what parts per billion level and whether it meets the MAL requirements or not. But the Euro 27 standard has a certain positive starting list. So you cannot use ingredients and components which are not present in the positive list. So that's very critical. There are many things which are being removed from the positive list. And one of the most, glaring example is that bisphenol A is no longer in the positive list starting 2027. So in theory, starting 2027, you could not get any approval for a epoxy lining for drinking water applications, which is really huge. So there are no bisphenol A, F, any bisphenol A or bisphenols are getting removed from the positive list because the positive list entry for bisphenol expires in 2027. So that is again going to be a very big change in the market as far as Europe is concerned. So that is something to be assessed by the industry.
Thank you. Thank you.
Mr. Mann, I want to take up another question with you, since you're mentioning, regulations related to drinking water. This polyurethane coating are becoming increasingly important for corrosion protection from a technical and commercial standpoint. What key advantages do you offer over conventional coating systems such as epoxy, cement mortar, or 3LP, or FBE, or coal tar based systems?
So basically, a polyurethane is a spray applied spray applied product, which is in effect means it is seamless end to end. You have no overlapping seams like conventional wraps. So for instance, in 3-layer polyethylene, you have an overlapping seam. In this, because it is liquid spray applied, end to end, it becomes seamless. And not only it is seamless, it is monolithic as well, which means there is a single film directly applied onto the blast clean metal. There are no multiple layers with inherent issues of likely disbondment over the longer period between dissimilar layers. So for instance, in systems like 3-layer polyethylene, there are 3 layers which each serve a different purpose. The base fusion bond layer serves as the corrosion protection layer. The outermost polyethylene polypropylene layer serves as a mechanical protection to the base layer. And there is an intervening layer of the copolymer adhesive, which bonds the innermost and outermost layer together. But in the case of the polyurethane, a single layer provides corrosion protection, high electrical resistance, yet it is mechanically so strong that it does not require any additional protective layer. So a single layer monolithic surface. Then there are several other advantages. It's a very fast cure system. We are spray applying externally on a skew conveyor with setting times as low as 20 seconds. So you can, instead of spraying on a turning roll, we are spray applying on a skew conveyor in maybe like 60 seconds. The coating is ready for a holiday detection and no DFT check and dispatch. There is minimal heating requirement. The pipe has only to be warmed till maybe 50 centigrade, 50-55. Compared to conventional coatings, wherein you have to heat the pipe to 200, you have to melt powders, put them on, and then you have to quench them with water. Then the second process starts. There's a lot of heat energy requirement, which gives it a very high carbon footprint and high CGH emission. Whereas in the case of polyurethanes, is practically a cold applied and cold cured product, which is a very minimal environmental impact. And finally, because the capex is very low, you can convert an existing plant which is applying say fusion bond or a 3-layer polyethylene to have a capacity to apply polyurethane just by investing maybe around $50,000 in a spray machine. And because of this very low capex and the low energy requirements, the application costs are very low. So it gives a very good commercial advantage as well. The total installed price of the polyurethanes are much lower because of these factors. So these are some of the benefits.
Sorry to interrupt. Is it a made in India technology or it's imported?
So originally, it was developed in two places simultaneously, almost in Germany by TIB and by Zebron Corporation in the US. Now I'm talking, this is late 1980s. We acquired the know-how around the year 95. So since 95, we are manufacturing in India. So we are almost, like we have a parallel history in the international market as well. So for 30 years now, it is being made in India. Of course, the original products are very different from what we make now, but in a sense, it is a made in India product.
Thank you so much, Mr. Mann. Now coming to David. David, I want to understand how important is timely condition assessment in deciding whether a pipeline should be rehabilitated or replaced, and what are the consequences of delaying rehabilitation in terms of water quality or leakage or operational cost? David, please unmute.
As one of the other speakers mentioned, obviously it's the laying of the pipe which is critical to stop failures and so on and so on. I mean, I'm heavily involved in condition assessment over in the Middle East, and we've now picked up some very large projects that basically we're inspecting the pipes from outside without turning the water off. So hence some of these critical pipelines in Saudi Arabia, what are running at 45 bar, taking water from Jubail desalination plant over to Riyadh. These can't be turned off, but we have now been working with a company in Australia and Adelaide University, and it's just been approved by Abu Dhabi Water, Thakur, for use, and they're happy. It's all been tested, trialed, and so hence what I would say, i.e. if we're doing a pipeline, the cement lining will only fail if the pipeline fails, i.e. if the outer coating's been damaged, laying, water gets behind it, corrosion starts place, then you'll get a blowout and make eruption, and that will destroy some of the internal lining. Then it's got to be dug out, replaced, and so on and so on. So I'm a great believer because I've also got a lot of experience in the wastewater where they do frequency inspections. I'm a great believer in condition assessment, i.e. if you want to look at your pipeline if it's a critical pipeline and these are costing millions and millions of dollars, have a look at your pipeline at 5 years, after 5 years. See if there's any, because most of the problems internally are caused by trapped air blockages, which is causing water hammers and so on, and this is where it can damage the internal lining as well as the pipe. So if you, i.e. the asset's worth that much, and this is where asset management is big in the Western world, because the asset's worth X amount, we've got to save it, and it's got to be budgeted. So, i.e. you have a look at your pipeline after five years. You'll see if you've got any problems in there. You'll see if you've got any maintenance. These condition assessments now are measuring the thickness on average of the pipe, where the corrosion is. If you've got, i.e. cement line loss, it'll also pick up blockages, air traps, and so on and so on. It'll give you a full report on the actual pipeline, so you know if you've got reduced thickness of the steel pipeline in certain areas. There's something gone wrong internally or externally, and that's when you start your maintenance. As you further go past the first inspection, then you take your second one, say maybe at 12 years, and then your frequency should start more. You can actually see how the pipeline is surviving. You can then kind of say this pipeline is going to last us so longer and so long and so long. So I'm a great believer in condition assessment. That's now big. It's coming to the Middle East from Europe. Everyone's involved in condition assessment because, i.e., as I always say, it's like if you go to the doctor for regular checkups, they'll find out your problems, and it's easy to address when they're small or such. If you leave it, then failures will happen and it will damage the pipeline. It can also then, as they do, you can plan your rehabilitation around your condition assessments and so on and so on. So you know, okay, the way this pipe, after 12, 15 years, the way this pipeline's gonna, it could last for another 10, 15 years. We're predicting this, and then thereafter you can actually, this is new pipe now going in the ground. You can then plan your rehabilitation. Obviously, your older pipelines, which have got problems, kind of need condition assessment as soon as, and see where the problems are, and seeing the extreme of the problems, and not just waiting for burst after burst after burst, and so on and so on. So
yeah. David. Rakesh, you wanted to ask a question from David. You have any question?
Yeah. So David, we understand for CML it takes quite a long time for curing. So would you like to, explain the CML more about it? Like, what are the common misconceptions we have about CML, and if you'd like to address it for considering Indian market?
Well, as I kind of briefed on before, the way it works, we would set up adjacent to your construction site. So if you've got an 80-kilometer pipeline, say 60, 64 inch, we will set up and we'll try and measure it that we're based in the middle. Pipe deliveries will come to us, and we line the pipe. Obviously, it's going to be welded because it's carbon steel. We'll do a cutback, which then the cutback can be knocked out as you're laying the pipe, welded. We go in and do the internal joint with CML. Prior to us lining the pipe in the yard, then it'll be inspected the day after, and it's being inspected as it's being lined. The alkilometers are out, thickness gauge, Hayes and William formula, and everything else it's all governed and properly inspected. Then, as a lot of the clients or Whitco, SWIC are asking for 28 days curing. We've got on the compressive testing and the bending tests, we are reaching the desired and passing by a lot more at day 7. So, but on majority, curing will be 28 days. Thereafter, it can be taken to site. So, i.e., if you've got 1 crew lining, 2 crews lining, obviously the schedule of laying is needed. You just start the lining 1 month before, 1 month before, and then you'll get your pipes going in the ground as such. That's all coordination. So it's not something big to worry about. That if you're doing a project, we set up the pipelines. The pipes are being lined. Majority of my pipelines I'm running there, we're still waiting for the contractor to take the first pipes. 3 months later, basically. So.
Right, David. So, following the question of misconception, I want to go to Mr. Maheshkumar. Mahesh, sir, there are many misconceptions surrounding coating standards and specifications. What are some myths you frequently encounter in the industry that needs to be addressed?
Well, see, there are many misunderstandings are created because of lower understanding about the specification, lower understanding about the environmental condition, and actual utilization of that particular lining. Now, our Arunji must have encountered this with lot of TPIs. The TPIs will be going ahead with what is that written in the specification. That is the third party inspector's job, and they are doing it. Now, the third party job inspector will sit on such parameters which are irrelevant. For example, there is one particular parameter given into the linings that you should measure the surety hardness of one particular lining. Now, as far as surety hardness is concerned, it is a concern. It concerns with the cure of the material. It has nothing to do as a property of the material. Okay, so this is myth, and in that particular specification, if it is written that you have to achieve say the surety hardness of 85, they will stand for that. But some of the coatings will cure even at 77, 76 surety hardness, and that is enough. That is enough to go ahead and utilize that particular coating. If you go on increasing the surety hardness, what is going to happen? The coating is going to become rigid. Now, Mr. Shomendra will definitely back me by saying that as and when you go on increasing the hardness, you are going to increase the brittleness, and that brittleness is useless because the pipes are so heavy. The pipes are so heavy that such type of brittleness will not allow the coating to stand there. So what you need a coating which should be flexible enough, which should be able to take up the shocks, which should be able to take up the environmental, whatever the conditions there are. It may be very cold, it may be very hot. During that particular time, when it is cold, it should shrink. When it is hot, it should expand. All those things should happen with that particular coating. And that particular myth that no, you have not achieved the surety hardness, coating is fail. That kind of things are not known to the third party inspectors, and unnecessarily the people, those who are working in the pipeline industry, are getting harassed by them. I'm sorry, Arunji, you may counter this that it is harassed, and I don't want to say that particular word, but the fact is fact. Means most of the time is wasted by the third party inspector, in which Arunji may have continued and could have created pipelines worth lakhs of rupees, isn't it, sir? That's it. that these kind of myths. So the first and biggest myth is not understanding the specification and the use of specification in the real world. They just understand only the paper.
You're absolutely
Yes.
right, and this will be reflected very soon in our poll questions also, where I have taken up this question from our audience. How well do you understand the standards by BIS or AWA or any international body? So I'm just giving a reminder to our audience that we have raised a poll, and I request all of you to participate in that poll questions. So the question what we were asked is, what sector do you represent? It is on your screen. You can select the option and respond. Then the question number 2 was, what is the biggest challenge in ensuring long-term pipeline performance? The options are in front of you. So these questions, this reminder is for those people who joined us late. And then the question number 3, which we asked from the audience, is what is the most important factor when selecting a coating systems? Then you can make a selection. And the question number 4 is, how familiar are you with BIS, AWA, ISO coating standards? You can do your voting. And the question number 5, which we asked, is, in your opinion, what contributes the most in extending a pipeline service life? So audience, please continue to vote. And Rakesh, you wanted to ask another question from Mr. Mahesh.
Yeah, Mr. Mahesh, you have highlighted some of the points in your last answering the last question. I'm continuing that. In oil and gas application, pipeline often operate under extremely harsh environments.
Yeah.
So, in your views, what are the top 3 or 4 points which asset owners should prioritize while specifying or selecting the coating system? If you would like to identify top 4 things rather than over specifying or under specifying, the right specification.
Right specification. You are 100% correct. Now the point here is, whenever the performance is considered for the oil and gas pipeline, there are 3 types of oil and gas pipeline. One is carrier pipelines, which are carrying the crude and all those things to the main tanks, it is crude oil tanks and all. Other are the finished line pipelines, where you are taking the finished products like ATF, like petrol, like diesel, and that is carried out. Okay. Now, in this case, the selection process is very, very important. Now, when you talk about the crude oil may consist from 3 to 9% of seawater. In some cases, if it is a burnt crude, it could be more than that. It could be around 11%. Now, the salt content in that particular seawater can extremely dangerous. In some cases, where if you go to our east, like Paradip, these particular area, the salt content is very, very high. If you go to our north, like your Gujarat, Rajkot area, the salt content is much lower than that of the Paradip. Okay. So wherever that particular crude is taken, one should know the concentration about it. So the specification for making a crude oil pipeline internal coating, it should be considering a much higher concentrations of salt, whereas currently the coatings which are manufactured are less than 7% salt content. They are the tests which are carried out are also having a lower range of testing. Now the coatings can be tested to the ranges like EIS, that is electrical impedance spectrophotography, EIS. This is also available. Then there are the coatings which are applicable for handling the hot crude oil. Now, when it is a hot crude oil, the external of the pipeline is always insulated one. Now, if you look at the NACE International specifications, NACE International is a body which does not specify any type of coating. There are thousands of standards by NACE International. Okay, but none of the standards specifies the coating. There is only one standard, NACE SP108. It specifies a coating for the pipeline, those which are insulated one. And it specifies only the thermally sprayed aluminum. Okay, people go with compromised system. Instead of using thermally sprayed aluminum or multimatrix coatings, they may go for phenolic coatings. These phenolic coatings becomes rigid. Okay, and once they become rigid, they will not tolerate the thermal shock. And if they are not tolerating the thermal shock, the ultimate result is failure. So the most important thing is, whenever you are looking at the specification, deriving a specification for the oil and gas pipeline, one must study which area, how, where, and that is possible. See, at this moment of time, pipeline industry is so transparent that they are sharing each and every detail of the pipe. They are sharing each and every number of the pipe. It is traceable to the small T's and bends.
Yes, sir.
They are traceable. So if they are providing it, they can definitely look into the selection of the coatings into that particular area with coordinating with the such a people, such a pipeline industries, those who are providing those details.
All right, sir. Thank you so much, Mahesh, sir. Now I'm going forward to Arun Gupta, sir, from Jindal, sir. Rakesh, you want to take up a question to Arun, sir? And also, I request all the speakers to check you are receiving questions from the audience, which we will take up once we are through with our questions. Yeah, Rakesh.
Yeah, Arunji.
Yes, please.
Thank you for explaining. You were taking us through the history of the introduction of coatings in India, starting from 1984 through PSL, and then as well started by Jindal in 1995. So what is the real reason for so far for 3LP being the preferred choice of coating through the pipelines? Is it the reason because this is the one which was available? And at the same time, do share the key challenges, particularly in terms of field joints, the repairs of 3LP coating, and transportation of large diameters of 3LP coated pipes in the projects. Thank you.
No, our experience is that we have very long experience with 3LP, and we are getting good results with that. For buried pipelines, I think 3LP, people like in US, they ask for FB coating or DFB coating. But in Gulf countries, in India, the most popular coating is 3-layer polyethylene coating for buried pipelines, onshore pipelines. For offshore, they are asking for polypropylene coating, and both are giving very good results. Regarding this failure or girth weld coating, that's the most critical area. If you will see, most of the failures are from the girth weld coating.
Yes.
Because it is not possible the online process. So they are applying the heat shrinkable sleeves. That's a very good option. but not as good as the original coating applied in the plant. Second thing is the honesty at the time of blasting, and the most important thing is surface preparation. At the site, when they are applying the sleeve, they have to do the manual blasting. Sometimes it is very difficult to blast the pipes from downside. So the team who is working on that, they must be very honest, whatever problem they are facing, but they have to prepare the actual surface preparation on downside also. And then they have to apply the sleeves in a very proper way. Then it will be okay. If you will think about this internal coating, girth weld coating, difficult, especially in water pipelines. I heard from few clients, when we are making the cutback in internal coating, we are applied the tape before paint application. And after that, we are removing that. But there are clients in India who don't want to go for blasting at site. So you know what? They are adopting a shortcut. They are asking that please do not remove that tape from that area. Then they are taking the pipes with tape, they are welding, then they are removing the tape, no blasting, then they are applying the paint. In my opinion, they should not adopt this procedure. Otherwise, the weakest area is girth weld. They are spending so much money on pipeline coating and they are saving some money or maybe some times, I don't know what is the reason. And they are making some weak area.
And how about transportation, sir? You are one of the major exporters of 3LP coated pipelines across Middle East. And a lot of cases has been seen when the pipe arrives here at site, a lot of damages on the body of the 3LP coated pipes. How do you address that, or how do you safeguard it?
Yeah, that is also a challenge. When you are loading the pipes in shipment, if it is export projects, but the biggest challenge in domestic sites, they want to save the money in logistic. They are doing the nesting even in coated pipes outside inside. There are much more chances of damaging the coating, but they are saving the money in logistic. So that is the biggest challenge. We have supplied more than 200 kilometers pipeline to the Neom, Saudi Arabia. There was very less damage. There is no complaint at all about coating or coating damages or anything, because when we are loading the pipes at Mudra port, we have our team to take care of this. Then we send our team at Saudi. So you have to take care of that.
And Arun sir, if we ask about the external coatings, how often expected to last? As in, we usually hear it can last several decades.
Officially,
what factors most commonly reduce coating life in actual field conditions?
Mostly the failure started from the girth welds. Otherwise, we are officially saying 25 or 30 years for the pipeline, but I can say 40 years, 50 years, nothing will happen if we have applied the coating in a proper manner.
And another question which I want to take from you is, how are automation and digital inspection technologies improving coating qualities and consistency in manufacturing plants today?
Ma'am, to be very frank, there is not much digital inspection or automation or something in coating, but we are thinking on that. Like some parameters, it is displayed digitally or something, but like thickness checking or inspections, there is no much improvement in that. We are thinking on that, but still it is not up to the mark.
Thank you, Arun sir. So audience, we are now ending the poll and the results are in front of you. So the question number 1 was, which sector do you represent majority of So we have received a mixed result, and the majority has gone to the coating. Then the second highest is on steel producers, and then the water and oil and gas. And then we have EPC consultants. The question number 2 was, what is the biggest challenges ensuring long-term pipeline performance? 48%, which is a maximum, have gone to the corrosion. Biggest challenge is corrosion. Then we asked, what is the most important factor when selecting a coating system? So for this, the maximum voting has gone to throughout the project life cycle. Important factor when selecting a coating system is people have voted for throughout the project's life cycle. And then we asked the question, how familiar are you with BIS, our ISO coating standards? Uh, so the highest voting has gone to basic knowledge, which is 36%. A lot of people have responded to somewhat, not familiar at all, and little bit familiar or very familiar. And then as in there is a huge gap on understanding of standards, which we can clearly see from this poll. And this is what we were discussing, Maheshji um, and Mr. Mann. And then the question we asked, in your opinion, what contributes the most to extending a pipeline service life? The 52% of vote has gone to high performance coating. This clearly shows that the coating plays a very heavy role in pipeline, life. I hope you all have seen the questions the audience have taken up from us. So we have a question from Alok Jain. He is asking from Mr. Mann that when he is working with standard upgradation, he should also focus on putting more inspection. Okay, it's a comment, it's not a question. More inspection and automation during application to be incorporated in these standards. You want to make a comment to this, Mr. Mann?
No, I will keep it in mind. In fact, I wanted to speak something about because a lot of conversation was there on the girth weights. So if I may, can I speak about the recent innovation?
Yes.
Okay, great. So I agree completely with Arun sir and Mr. Mahesh. The girth weld or the weld joint coating is the most crucial, and invariably in most sites nobody is really doing proper blasting. The contractor will just skip, or he will do a shoddy job. No, so the blast cleaning is really not being done in the girth welds. We have had a look at this over several years now, and after working for several years, we have come out with a system which we call no blast. It's like a simple a term. No blast is a system which gives high performance on a non-blast clean surface, on a ST2 surface. So what it comprises is basically 2 layers. The first layer is a viscoelastic tape, which as per AWA C232 and ISO 21809-3, followed by a polyurethane 1000 microns. This system can be applied without blast cleaning on a ST2 surface. It is a very long-term, very high-performance system. So perhaps for the first time, we have the possibility of having a long-term solution to corrosion protection of an area where the blast cleaning has not been done to the same standard as the main pipe coating. So this is a very relatively recent innovation, but it has a lot of promise and it is testing extremely well. So this is
okay. There's a question from NMDC. They want to ask if somebody can suggest what is the best coating for coke oven gas pipeline inside for an integrated steel plant. So if any coating expert can make a suggestion.
Can I?
Yes, sir. Mahesh, sir.
For the coke pipeline, you have to think about what is the temperature. If the temperature is more than 120 degrees centigrade, please keep it with what we call it as a thermal spray aluminum, and otherwise there is no other coating. Polymeric coating, forget it.
Okay. And there's a question from Samarth Vijay. Can the speaker elaborate on coating that can be applied to oil and gas well casing and tubbing, specifically in acidic service pH 3.2 greater than 3.2? How would the coupling be handled? Anyone can respond to this. So I hope the questions are visible on your screen. No, so we will pass this and maybe we will respond by email, Mr. Samarth Vijay. You can write it to us. So there's another question. It is a nice discussion. I have a question related to metallic coating over pipelines. What are the challenges and what type of testing play a crucial role in identifying technical issues such as EIS or scanning electron microscopy? Please suggest approaches for root cause analysis and prevention for the future.
So, right, in fact, it's a very interesting question. EIS is playing an increasingly important role in assessing the performance because EIS is determining what is happening at the interface between the steel and the coating. That's where really the failure takes place. What we have done recently is that we have collaborated with a major laboratory in the US and we have sent them 5 coating systems for parallel testing. So these are polyurethane, 3-layer polyethylene fusion bond, the viscoelastic, several coating systems, and we are running tests in which there will be a DC voltage and we will assess the performance of every coating under identical circumstance using DC voltage and EIS. Because when we talk about cathodic disbondment, that is only from in damaged area. So whatever adjacent coating peels off due to cathodic protection currents, that's a cathodic disbondment test. But what we have seen in real life is that the main cause of failures seems to be electroend-osmosis, which is the transmission of corroding substances through a coating film. Even if the film is intact, the electric current, the DC current actually drives corroding products or through the film into the surface, and over the period, that's what causes ultimate failure. So this is a first of its kind testing which we are conducting, which will involve the EIS assessment simultaneously with visual assessment like blistering, etc., and also the specific electrical insulation resistance of the coating system. So EIS is a very, very important technique which we are using. In fact, there was, ma'am, if you missed, there was a question on ductile iron pipe as well.
Yes.
If I may, I would like to address that also.
Okay.
So ductile iron pipes, a lot of them are being externally coated and internally lined with polyurethanes. The international standards for the external side is EN 15189, and for internal lining, it's EN 15655. About 1,000 microns of polyurethane direct to metal. In fact, Jindal Saw is a major user. Jindal Saw in the UAE is using a large volume of ductile iron, polyurethanes for ductile iron, and exporting the coated pipes in Middle East and elsewhere. So for ductile iron, polyurethane is a very well established internal lining and external coating. So if they could contact me offline, I can maybe help them.
So I'm taking the last question. Why no coating for coke oven area with 120 degrees Celsius? What about multi-polymeric matrix coating?
Multi-polymeric matrix coatings is basically for atmospheric exposure areas or coating under insulation. When the question was for internal coating. Internal coating you need a highest corrosion resistance. Multimatrix polymeric coating withstand maximum up to I'm saying 2000 hours of salt spray. These are not that much. These are not that much corrosion resistance, though they are temperature resistant. The internal area of the pipeline is more severe than that of the external area. And that's the reason multimatrix polymeric coatings are not suggested for the internal of the pipeline. It is for the external of the pipeline, and that too under insulation. You can apply multimatrix coatings after application of TSA just for the sealing of the TSA, that is thermally spread aluminum.
Right. So now we have also exceeded our time by 12 minutes. It usually happens with the technical webinars. People are so enthusiastic. They have so many questions. And then we also want to address as many as questions as we can. But then we have to conclude this webinar. And I also like to inform our viewers that we will be doing a conference on coating technologies. Very soon we will be making an announcement. And till then, I would like to thank our panelists, starting from Mr. Mann, founder and director, Amchem Product India. I would like to thank Mr. David Peck, Operations and Project Manager at Tabteen and Corrosion Prevention Technology Company, Mr. Maheshkumar Aradhye, PCS, Senior Director, R&D, Protective Coating and General Industries used at Nippon Paints India. I want to thank Mr. Arun Kumar Gupta, Associate VP, Operations at Jindal Saw Limited. And last but not least, my co-moderator, Mr. Rakesh Thakur, founder of Pipeline Solution Service from Dubai. And audience, really thank you for this engaging discussion, and to our panelists also for answering so many questions. To our audience, we will be meeting soon with our next webinar and next conference. Please do not miss out to take details about our next programs from our website, Metalogic Events. Also, we have our 9th annual conference on Make in Steel, Make in Bharat on 13th of August at Lee Meridian, New Delhi. So do not miss to attend. There, the focus is on alloy steel applications for defense and critical industries. Thank you so much, everyone. And thank you for joining us today, and have a great evening, sir.
Thank you.
Thank
Bye-bye.
you.
Thank you so
Bye.
much. Bye.